Hello, ladies and gentlemen. Today we're going to take a look at multiplying and dividing rational expressions. For this, you're going to need your notes, something to write with, and of course that calculator is going to come in handy as we go about factoring. So let's remind ourselves of our objective here, what our big plan is. We're trying to learn how to simplify rational expressions accurately. So we've worked on just basic simplifying, and now we're going to take a look at some operations with multiplying and dividing. So remember our basic fraction rules. The basic fraction rules that we talked about involved multiplying fractions, and that was a reminder that we need to multiply straight across. So when a fraction is like 1/4 times 1/5 here, we know that we should multiply straight across and get an answer of 1/20. Okay, 4 times 5 is 20. Now, dividing, we also said, is pretty simple. We just reciprocate that second fraction, flip it over, and change it to multiplication. So if we have 1/4 divided by 1/5, we'd go ahead and turn that into 1/4 times 5 over 1. We'd reciprocal that guy right there, okay? And then multiply straight across, 5 over 4. That's our final answer. Now remember, always in the end, anytime we're dealing with fractions here, we need to make sure that our final answer is as simplified as it can get. So always make sure that we're simplifying our answers, especially at the very end, that it makes sense. So when we go about doing ours now, we go ahead and we take a step further without just the simple fractions, and we're going to put expressions in there, okay, algebraic expressions. So go ahead and type this one, write this one in your notes. Multiplying, we are going to think about factoring these first, okay, ladies and gentlemen? So rather than multiplying and distributing things times each other here, we're going to factor it first and see where that leads us. That's really the key to multiplying and dividing. So take a look at these two fractions we have here, and let's go ahead and factor each part. So the top right here, okay, the numerator of that first fraction, what can I do to factor that? Well, I can take a 2 and an x out. And if I do that, if I divide each piece here by 2 and x, then it would become x minus 5. 10 divided by 2 is 5. So the numerator of that fraction factors into 2x times the quantity of x minus 5. Well, what about the denominator of that fraction, or the bottom? Let's take a look. That 25 is a perfect square. So we should remember that that would factor into x plus 5, x minus 5. And now we're going to take that and multiply it by this second fraction here, which happens to have an x plus 3. Usually you'd see those guys together trapped in some parentheses like that. And then an x, 2x squared. Now if we look at this, you guys, and we say, well, what's happening here? See, when we factored it now, we made an opportunity for us to simplify or cancel factors. Check out this x minus 5 is a factor. So is this. We can go ahead and cancel that or simplify that. And now if we take a look at what we have left and we just multiply straight across here, you don't actually have to multiply it out, but just write what you have. On the numerator, we would have a 2x from the first fraction times an x plus 3 from the second fraction. And in the denominator, we would have the 2x squared, second fraction, out in front of an x plus 5. Now look at that now. Is there more terms or pieces here that we can go ahead and factor or cancel? Well, 2x and 2x squared are made up of similar factors there. Looks like I can go ahead and cancel the 2, and then one of these x's will also cancel as well. So we'd have an x left on the bottom. So take a look at our final answer. X plus 3 over an x times an x plus 5. Okay, so this is the process we use when we go ahead and simplify rational expressions. We take a look at their factors, see if anything can cancel for us or divide out of the top and bottom, and then we can go ahead and write what we have left. So let's take a look at this next one, multiplying again, but we know that we should factor first. So numerator, denominator, we need to find the factors of these guys or we need to break them apart. So here, let's look at the numerator first fraction. What can I do to that to factor it? Well, it looks like I can take out a greatest common factor, 4 and an x, leaving me with an x minus 1 if I go ahead and divide 4 by 4 there. Now in the bottom here, this is a trinomial. This would be a situation where we would go ahead and take the a times the c, what multiplies to make -3 and adds to make +2. Now in this case, -3, +2, let's see, what multiplies to make -3 and adds to make +2? How about 3x and -1x here? And then we'll go ahead and factor out all the pieces, and we go ahead and find out that he is x plus 3 and x minus 1. So again, see how factoring has helped us find some factors that can go ahead and cancel. Look, we have x minus 1s over x minus 1s here. But let's keep going to the second fraction. What about this guy? What multiplies to make -6 and adds to make +1? How about 3x, 2x? If that 2 is a negative, that would do it. So x minus 2, x, 3. So we have factors of x plus 3 and x minus 2. And remember, the denominator there has still 4x. So now if we take a look at what's happening, we can try to start to see these factors that would cancel each other out. Remember, you can cancel factors, but you cannot cancel terms. So x plus 3 over an x plus 3 here, ladies and gentlemen, even though they're in two separate fractions here, when I multiply straight across, they would have become one single fraction. And we also have those x minus 1s that we had in common there. What about the 4x and the 4x? The 4x is also a factor. Okay, he's not being added or subtracted to anybody else. So the 4x can cancel with the 4x. And what's left then? Just my x minus 2. And you can leave the parentheses around it, you can put it over 1, whatever you need to do, but that's the only part that's left here. So when I broke everything apart and was asked to multiply, good things happened and things would cancel before I actually had to multiply them by anything. So let's take a look at a third example. Similar idea, same idea here. We have fraction times, and remember that big polynomial there, that quadratic? He is also a fraction in disguise. Over 1, that's right. So let's go ahead and factor each part. Numerator, first fraction. Just an x plus 2, really can't do much with that. X plus 2, leave them alone. What about the denominator? That's a difference of perfect squares. 4 is a perfect square number. So he becomes x plus 2, x minus 2. Second fraction, numerator. What multiplies to make 9 and adds to make 6? 3 and 3, right. So we'd have 3x, x squared. So we'll go ahead and factor. Oops, that's an x. 3x, 3. So we'd end up with x plus 3 times another x plus 3. And the denominator's just 1. So now if we take a look at what's going to happen here, remember you can write them all the way across what you have left. Look for things, factors that are going to cancel here. X plus 2 over an x plus 2. That's it in terms of canceling factors, okay? The x plus 3's are together in the numerator. They will not cancel each other out. So what would we have left? Well, if I was going to take this another step further, we'd have 2 of these in the numerator. So x plus 3 squared, because there'd be 2 of them. And then in the bottom, the denominator here, we'd have an x minus 2 times a 1, so you can put that 1 in front, or it just stays x minus 2 when you actually multiply it. So this is how I would leave my final answer. One more, the dividing problem, okay? One division. Here we go. Remember the rule with division. Division means that we're going to go ahead and take the reciprocal of that second fraction. Division is the same as multiplying by the reciprocal. So we're going to go ahead and change this to a times sign right here, but then I have to take the reciprocal, so I have to flip this fraction over. So I'm going to do that right away so I can see what I have here, and then I'm going to go ahead and factor. First fraction, numerator 2x, just going to leave them as a 2x. That's a factor already. That's 2 times x. Now in the bottom here, looks like I can take a 3 out of each of those. Greatest common factor, x minus 4 would be what I have left, times, then go to my second fraction, numerator. Three terms, trinomials, AC method. What would multiply to make 8 and add to make -6? -4, -2. So we'll go ahead and take out all of the pieces there. Greatest common factor of each row and column, and that leads me to x minus 4 times x minus 2 in the numerator. Now the denominator does not have three pieces there. He's not a trinomial, so let's turn to something else. How about a greatest common factor there? We could take out an x. That would leave me with an x minus 2. So now if I'm looking to cancel things here or to divide out factors that are in common, x minus 4 over an x minus 4, x minus 2 over x minus 2. What would I have left then? Well, in the numerator, I'd have a 2x. In the denominator, I'd have a 3x. Could I take this one step further? Answer, yes. Okay, 2 is 2 times x, 3 is 3 times x. We can go ahead and cancel those x's, and that would be the answer of 2/3. Okay, this is a real funny way of writing 2/3, but that is what it simplifies to make. So this idea of multiplying and dividing rational expressions, think about factoring, think about canceling factors or dividing factors out. That's a very important step, and then always make sure your final answer is as simplified as we can get. Thank you very much for taking good notes.